Hello, everyone. My name is Brandon Prenger, and I am currently a senior computer science student at Wright State University. I have a lot of interest in machine learning and artificial intelligence, and I am currently enrolled in an introductory machine learning course, so I made this project for that course. I'll be doing an independent study in the summer of 2020 to further expand this project, and I'm excited about it to say the least. So, one thing I really enjoy doing is watching NFL games and analyzing NFL statistics. One thing that irritates me is excessive arguing about sports on things that cannot be proven, though I am guilty of that myself. For that reason, I made this project using NFL statistics. More specifically, I wanted to look at how quarterback stats affected the outcome of the game. Everyone who has watched football knows that the quarterback is arguably the most important player on the field. I want to make it clear that this project predicts the outcome of the game given the stats from one team's quarterback for that game. It doesn't predict future games. More on that later. Now, my hypothesis is that quarterback stats are very crucial to the outcome of a game. This may seem obvious, but I wanted to look at just how important they are. I wanted a number. The first thing I did was I downloaded a dataset in CSV format. I downloaded an Excel file containing quarterback game logs from 1931 to 2016. It contained data from every single quarterback in this era, regardless of if they played or not. Obviously, this dataset is huge. Machine learning is useful when using huge datasets, but I still wanted to narrow the dataset down to make it more useful. So the first thing I did was I narrowed the dataset down to only years 2000 through 2016. 2016 is the most recent data the dataset has. I chose year 2000 because, as some of you may already be aware of, the game of football has changed significantly since 1931. Passing has become a lot more relevant in recent years. I'll talk on proving this later. I also narrowed the dataset down to only regular season games. In preseason games, the teams aren't using their best players and do not necessarily care as much about the outcome of the game, so I deemed this data useless. I didn't include the postseason because these games are played only between the best teams, and I wanted data that reflected NFL teams of all skill levels, such as the Cleveland Browns, who are terrible. The last thing I did to clean the data was pretty simple. I wanted to make sure that the quarterback actually played in the game. This one is obvious. Let's move on to the specific stats I evaluated. I used passes completed, passes attempted, passing yards, yards per attempt, touchdown passes, interceptions, sacks, fumbles lost, and rushing data on the quarterback, that being rushing yards, yards per carry, and rushing touchdowns. Some of you may not think that the rushing statistics for a quarterback will affect the outcome of the game much, but if you were to look at players like Michael Vick, you'll see why they're important. Michael Vick had a lot of rushing yards. I avoided using quarterback rating as a statistic because it is derived from some of the previous stats mentioned, and it is not really a perfect measurement. Discussing this argument is not in the scope of this project. So I used weeks 1 through 15 as the training data in this project. For those of you who don't know, the training data is what the algorithms learn from. I used week 16 for the test data, which is what the algorithms are tested on to see how accurate they are. It's important to know that I picked week 16 arbitrarily. I could have chosen something like week 2 as the testing data and the rest of the weeks as the training data, and the accuracy would be roughly the same. Again, this is something I will test in the future. It's important to remember that this project predicts the outcome of the game given the statistics for that game. At this point, it does not predict future games. Another thing I did to clean and filter the data was to get rid of all double hyphens. Unfortunately, the dataset was mixed with zeros and double hyphens that both indicated the same thing. The last thing I did was to count tie games as losses for the evaluated quarterback's team. Firstly, it is not a win, which is what's important. Also, if I had kept ties in as a class, then the data might have been skewed, because almost every time it will be wrong in predicting a tie because these are rare occasions. I could be wrong on this, so this is something I will test in the future. I want to talk now about the algorithms I used and the evaluation metrics that I looked at. Discussing how these algorithms work is not in the scope of this video. If you have questions, please leave them in the comments. I first used logistic regression. The C-value I used in this algorithm was 13, since that gave the highest precision value. Some of the evaluation metrics I got were the area under the curve as 0.831 and the precision as 0.746. This means that it was accurate in predicting the outcome of the game 74.6% of the time given quarterback stats from one team. I also used a neural network. I used ReLU for my activation function with one layer of 80 neurons. This was the best number of layers and neurons I could find for a high precision. I used 0.0001 as my alpha value. The evaluation metrics for the neural network were 0.833 area under the curve and 0.758 for the precision. From this, I've learned that the neural network worked much better than the logistic regression model for this dataset. There were a few challenges I faced in this project. First, there was some learning I had to do on using the pandas library in Python. At first, I attempted to iterate through the dataset using a nested for loop to change the double hyphens to zeros like I previously mentioned. This proved to be difficult because of formatting issues, but using a pandas data frame made this process much easier. I also attempted to use only Python scripts in this project, but when trying to create and evaluate various models, I kept getting different errors such as mismatching number of rows, which I don't know what that meant because I don't know what it's comparing the number of rows in the dataset to. It could be that the evaluation metrics had a different number of rows, but that's something I'll find out in the future. To overcome this, I used Orange Visual Programming. This proved to be much easier. In the future, however, I'd only like to use Python scripts. One exciting thing about this project is that it definitely has implications to stretch farther into the sports statistics area. I could use a similar dataset to analyze outcomes in basketball, baseball, and other sports, as long as there's an ample amount of data. If I'm able to expand this project thoroughly and it works well, it could be used in sports betting. Remember that the hypothesis was that quarterback stats are very important in predicting the outcome of the game. Not surprisingly, this was proven to be true. I think that this is a sufficient evaluation. There's a lot of things I'm excited about with expanding this project. I could use different NFL stats, such as rushing stats, defensive stats, and even combine stats. As mentioned earlier, I could also test the accuracy of these models with changing which weeks are used as the testing data. Another variation I could make would be to use quarterback stats from both of the teams in a game. I'm certain that this will be more accurate than the current models, which is exactly what I'm looking for. Another thing that I mentioned earlier was proving that passing has become more relevant over time. Myself and other football fans could discuss extensively on why that is, but in my opinion, it is better to do this with numbers. The fact that passing has become more relevant is something that I could prove by using different eras, maybe like decades at a time, as training and testing data and plotting the accuracy of win and loss predictions over time. So probably the thing I'm most excited for is changing the project so that it actually predicts future games based on past statistics. Something like, if given quarterback stats from weeks 1 through 7 of a season, how accurately can a machine learning model predict the outcome of week 8? Maybe it could even go as far as to attempt to predict the score of that team, though I'm sure defensive stats for the opposing team will be needed for this to be anywhere near accurate. Again, this does not have to be limited just to quarterback stats. In general, this is not a novel idea. I'm sure that Vegas and serious sports bettors use some sort of predictive analysis with stats. As mentioned earlier, I'll be working on this project over the summer of 2020 to implement all or some of these ideas, and I'll be sure to upload a video to YouTube explaining it. And with that, I'd like to conclude explaining my project. If you have any questions about why I used certain algorithms, how these algorithms work, or any comments, then please leave them below and I will try to get back to them when I can. Thanks.